RoboSense EM4, pioneering the 1000-beam era in automotive LiDAR technology. The autonomous vehicle industry stands at a critical inflection point where perception technology determines the pace of commercial deployment. At the forefront of this transformation, RoboSense technology has unveiled the EM4, the world's first automotive LiDAR system to exceed 1,000 laser channels. With 1,080 beams delivering 1080p high-definition 3D perception, the EM4 represents not merely an incremental advancement but a fundamental shift in how vehicles perceive and navigate their environment. This breakthrough arrives at a pivotal moment when the industry is deeply divided over the necessity of LiDAR technology, with Tesla championing pure vision systems while most Chinese automakers embrace multi-sensor fusion approaches. The EM4's revolutionary performance stems from RoboSense's new digital architecture platform, marking a departure from traditional analog LiDAR designs. At its core, the system integrates advanced SPAD-SoC, single-photon avalanche diode system-on-chip, and VCSEL, vertical cavity surface-emitting laser, chips, enabling high-sensitivity digital detection that fundamentally transforms signal processing pathways. The digital architecture delivers several critical advantages. First, it enables lossless information flow from sensor to perception system, eliminating the signal degradation inherent in analog systems. Second, the 1080-core LEP, LiDAR echo processing, system processes 25.92 million points per second, a data throughput that would overwhelm traditional architectures. Third, the system achieves unprecedented angular resolution of 0.050 degrees times 0.025 degrees, providing the granular detail necessary for detecting small objects at extreme distances. Perhaps most significantly, the EM4 incorporates real-time lossless data compression technology, reducing bandwidth requirements from several gigabits to hundreds of megabits per second, a 60% compression rate. This innovation ensures compatibility with existing automotive Ethernet systems without requiring costly infrastructure upgrades, a critical consideration for mass adoption. The EM4's specifications translate into real-world capabilities that fundamentally alter the safety equation for autonomous vehicles. With a detection range of 300 meters at 10% reflectivity and a maximum range of 600 meters, the system extends the response window for intelligent driving systems by up to 70% compared to previous generation LiDARs. Consider the practical implications. The EM4 can detect a 40 by 25 centimeters black cardboard box at 250 meters, enabling emergency braking at speeds up to 181 kilometers per hour. For white vehicles, detection extends to 600 meters, supporting safe emergency maneuvers at speeds reaching 289 kilometers per hour. Even challenging targets like loose tires are identifiable at 170 meters, while traffic cones register clearly at 300 meters. These capabilities exceed the stringent requirements of NHTSA's Federal Motor Vehicle Safety Standard No. 127, which mandates automatic braking at 90 miles per hour for vehicle collisions and 45 miles per hour for pedestrian detection. The 1000-beam architecture addresses a critical limitation of previous 128-beam systems, small object detection. Where earlier LiDARs could only detect 10 to 20 centimeters objects at 30 to 40 meters, often insufficient for safe avoidance, the EM4 identifies such hazards at ranges exceeding 130 meters. This capability is essential for robo-taxi operations, where even minor road debris can damage vehicles and compromise service reliability. Real-world deployment demands consistent performance across diverse environmental conditions, and the EM4 incorporates multiple proprietary technologies to ensure reliability. The system's large echo processing model, trained on massive datasets through RoboSense WEAN AI model, precisely identifies and filters environmental noise from rain, fog, dust, and snow. In challenging scenarios like heavy rain at night, where traditional LiDARs might see their road surface detection range collapse to just 10 meters, the EM4 maintains an effective range exceeding 60 meters. The system employs an innovative, large spot size for near field, small spot size for far field, beam design that penetrates water droplets and contamination on the lens surface, ensuring consistent detection even when the sensor is partially obscured. High-reflection blooming suppression technology, based on RoboSense spatiotemporal mixed encoding patents, prevents the washing out of point cloud data near highly reflective surfaces like road signs or wet pavement. This ensures that critical details remain visible even in optically challenging environments. The EM4's launch occurs against the backdrop of an intensifying debate about LiDAR's role in autonomous vehicles. Tesla, under Elon Musk's leadership, continues to advocate for camera-only perception systems, arguing that humans navigate successfully with vision alone. This philosophy recently influenced XPeng's decision to remove LiDAR from its new P7 Plus sedan. However, the Chinese market tells a different story. Li Xiang, CEO of Li Auto, provocatively suggested that Tesla would adopt LiDAR if Elon Musk ever drove on a Chinese highway at night, highlighting the unique challenges of environments where trucks with broken taillights create dangerous edge cases for camera-based systems. The market data supports this multi-sensor approach. RoboSense sold 544,200 LiDAR units in 2024, a 113% increase from 2023, with 519,800 units deployed for ADAS applications. The EM4's capabilities align precisely with the requirements of large-scale robotaxi deployment. As these services transition from controlled pilot zones to open urban operations, perception systems must handle exponentially more complex scenarios, from highway merging to narrow residential streets. The EM4, particularly when paired with RoboSense E1 blind spot LiDAR in a 4+4 configuration, creates a perception envelope with no blind spots and exceptional range. Market projections underscore the opportunity. Frost & Sullivan forecasts the global robotaxi market reaching $66.6 billion by 2030 and $352.6 billion by 2035. Goldman Sachs predicts over 500,000 robotaxis operating across 10+ Chinese cities by 2030, with top-tier cities achieving profitability as early as 2026. The EM4's production readiness, already being deployed in passenger vehicles scheduled for market launch in late 2025, positions it as a critical enabler of this transformation. The EM4's impact extends beyond individual vehicles to the broader infrastructure of autonomous transportation. As cities invest in smart infrastructure, high-resolution LiDAR data could enable vehicle-to-infrastructure (V2I) communication that enhances system-wide safety and efficiency. The 1000-beam era opens possibilities for collaborative perception, where vehicles share high-definition environmental maps in real time. Moreover, the technology's applicability extends beyond automotive uses. RoboSense AC1, active camera, for robotics applications demonstrates how high-resolution 3D perception enables new categories of intelligent machines. As the cost curves for digital LiDAR continue to decline, we may see proliferation into delivery robots, industrial automation, and smart city applications.